Okay, let's write applyCaesarCipher, which takes a message and applies a cipher, which was actually supposedly used back in Caesar's time. A very simple way to encrypt a message. And that takes a message and takes amount of shift to shift the message. Okay? So you can have a message like we attack at dawn with a shift of 1 gives us this mess. And the deal is you shift the W by 1, well, X is after W by 1. The E would be shifted by 1 to give us F, the A by 1 to give us B, and so on. With these special things to note, one of which is capital letters remain capital, lowercase letters go to lowercase. Anything that's not a letter, we just leave alone. If you shift negatively, you go backwards or to the left, okay? So Z by -2 would go to X, right? X, Y, Z, okay? And C by -2 would go to A. Interestingly, A by -2 would go to Y because we wrap around. Y, Z, A. Okay, so there's the problem, and we can get going on it. But before we do that, I want to do a simpler problem. I want to do just for one character. So def, we can call this shift character, okay? And it'll take just a single character and a shift, okay? And what we're going to do is we're going to assume it's a letter. So it's an alphabetic. So it's A to Z or uppercase or lowercase. Great, okay? So now return 42. And anytime that you create your own function, you have to create your own test function. So def test shift character. And you'd have to write this, you bet you. Testing shift character. Print past, and we'll go ahead and call our test function to begin with. And now let's add some tests. So we'd assert that when you shift a lowercase a by 0, you should probably still get the lowercase a. But let's think about some other things. Okay, if we shift a lowercase a by 1, we should get a b. If we shift it by 2, we should get a c. If we shift a b by 2, we should probably get a d. What happens if we shift an a by -1? We want to get a z, okay? And what would happen if we were to shift an a by 25? We would also get a z, but by 26 would take us back home again to an a, okay? And so on. So now you can also do all these same things just for kicks, but you can do them with, where are we here, right here, capital A's, capital B. And if you do it with capitals, with uppercases, oh, what's that 1 there? A by 1 should give us a B. Okay, so uppercase A by 0 should give us uppercase A, uppercase B. Okay, so there we go. We have our test. Okay, so now we want to write shift character to pass these tests. Okay, so let's think about if we're going to start at B and shift by 2, or maybe D and shift by 3. D, E, F, G. Okay. So if our character is B, we want to start by thinking how far from A are we? We'll call that our offset. Our offset is the distance from the character to A. To do that, you have to use ORDs, because ORDs convert characters to their ASCII values. ORD C minus ORD A, and we're only going to worry about lowercase for now. Okay? So what is ORD of B minus ORD of A? That is 1. And ORD of, say, D minus ORD of A is 3. Because, let's think about this one. A, B, that's a distance of 1. Here, A, B, C, D, that's a distance of 3. So it's like the distance from this character to A. Okay, that's our offset. Then our new offset would be the original offset plus this shift. So if B is 1 away and we're shifting 2, this one should be 3 away. If D is already 3 away and we're shifting 3, this one should be 6 away. That's our new offset. Then our result would simply take and start with the ORD of A, add that new offset, and that gives us the ASCII value of this one, which we then convert back into a character. That's the basic idea. It's mostly right. It's a little bit wrong, but mostly right. Okay? So look, it got through all of these. It failed for us here on A of -1 because shift character of A minus 1 should have given us a lowercase z, but instead it gave us whatever that is. And the reason is because our new offset, well, what happened? It became negative. Can't become negative it has to wrap around. If it got larger, think about this. The new offset is the distance from A to the new letter. That distance clearly has to be between 0 and 25. If it got larger than 25, like to 26, you'd want to wrap it back to 0. This is a perfect use of mod. You want to mod it, that sum, against 26. Okay, the number of letters in the alphabet. Okay, so as we push past, if our offset goes 26, 27, 28, it wrapped back around. And also, by the way, if you go to -1, that wraps back, because what is -1 mod 26? That's 25, which is what we want. It wraps around the other way. So this now works beautifully for all the lowercase stuff, and now it just fails in the uppercase stuff. Because of course it did. We baked in lowercase into our solution. Okay? So we can now deal with casing if it's a lowercase, then this is our lowercase stuff. Otherwise, if it's an uppercase, this will be our uppercase stuff. Otherwise, what do you do if it's neither? You just return C, leave it alone. Okay? If it's uppercase, it works the same way, only use the uppercase rather than the lowercase. And it doesn't like the fact that we're using top level code here, right, in our little test function here. Let's turn off our test function. Okay? So now we're all the way down to CaesarCipher. In other words, we passed all our test cases here, okay, which is really cool. But let's go ahead and let's look at if we can just clean this code up a little bit, okay, because it works, but this code here is a near duplicate of this code here, okay. So what we can do instead is say if it's an alphabetic, we'll do all that. Now, if it's lower, if it's not lower, then we can just do an else here, right? Because we know it's alphabetic, so it has to be lower or upper here. So now here's the deal. See this here? This code uses lowercase a. This code uses uppercase a. So let's just copy that code and use it in both cases, but we'll call this our base char. And here, our base char will be lowercase a, and here our base char will be uppercase a. So now we only have to have this code once, which is nice, okay? And we run, and that still passes. It passes because we make it to test applyCaesarCipher, okay? So shift char the testing. Oops, actually we should turn the test on just for kicks. And actually let's turn off the linter just for a moment, okay? And we run it, and it said that it passed the shift char. Okay, so now let's do one more thing to clean it up. So we're assigning into base char, and we're assigning if it's lower to this, else to that. We do that in one line by using conditional assignment. It's lowercase if c dot is lower, else a. This one line does the same as these 4 lines. Do that. So we get our base character. We compute the offset from that base character. We compute the new offset by adding the shift, but we mod 26 so that we wrap around properly, and then we convert it back by going from the base char with the new offset and turning it back into a character. And if it's not an alphabetic, we just leave it alone. We don't shift it. Okay, and we run this, and sure enough, our shift character. So now we have a nice clean shift character. Great. So let's take that code. Let's go down here. Let's turn off our test shift character, and let's write applyCaesarCipher now, because now this is easy. To apply a CaesarCipher, you have a result. You go for every character in the message, and you add to the result, shifting that character by the shift. If it's not alphabetic, we'll just get the unshifted character. If it is alphabetic, we'll do that cool shift that we've just heavily tested. And that's it. We'll return the result. Believe it or not, this is it. The top-down design put all the work in shift character, which is this function right here. And when we run this, it works. That is a solution. Now we could, of course, have put all this code right in here, but this is a much cleaner design, pulling out the individual character. And we think we're left with a nice clean solution to apply CaesarCipher.